This brief tutorial video is designed to show you how you might use these GeoGebra worksheets on volume and surface area of solids. On this page at the old GeoGebra wiki, a middle school math teacher from Florida named Louis Prisco designed a number of very clever worksheets that allow students to change the different attributes of solids such as cones, cylinders, prisms, pyramids, and spheres. For example, the one on the cone, which I'll be using in this tutorial, although the method will work for any of the solids, allows you to adjust. In this case, for the cone, you can adjust the cone's radius to different values. You can also adjust the cone's height, and you can see on the actual diagram there of the cone, the SH refers to the slant height of the cone, and that changes automatically depending on the radius and the height of the cone. Prior to doing these activities with students, I've used this with Math 8 students. You might use this with geometry students as well, but sometimes students have forgotten all about surface area, all about volume. They kind of remember the formulas, kind of don't. And so perhaps a good sort of preface or lead-in for these worksheets is an interactive at the Annenberg Learner website on three-dimensional shapes. And in particular, you can go through the intro and it talks about the difference between 2D and 3D shapes, about the difference between surface area and volume. But if you click on the surface area and volume link, it has some very good resources for finding the surface area and volume of rectangles and cylinders, or sorry, rectangular prisms and cylinders. One of the useful things you might find is that there are animations that help students visualize the net of these three-dimensional solids. And this will help students go beyond just memorizing formulas to an actual conceptual understanding of how to find surface area and volume for these solids. So this is a very useful sort of refresher site for students who need some more practice with surface area and volume before you get into these worksheets. So one of the more difficult things in the SOL standards for students, at least my Math 8 students, is finding out what actually happens when you say you double the height or you halve the radius. How does that affect the surface area and how does that affect the volume? And so what I might do in my classes is try and elicit from students, do you remember how to find the volume of a cone? Do you remember how you find the surface area? And so the checkboxes over here on the right help students to not only remember or see what the formulas are, but it'll actually calculate the solution for volume and surface area as well. And so once you've elicited some guesses from students about the formula for volume, you can check the box and it will actually show you that, and this may be a little different than it's presented on the SOL formula sheet, but it actually shows you how to find the volume of the cone. Then you can actually use the values of 2 for the radius and 4 for the height and have students work out on their own, either on mini whiteboards or perhaps on sheets of paper, what the solution for the volume of this cone would be. And so if you check that box, we can see that in this case be roughly about 16.75 cubic units. So this might be useful to have students just do some practice problems and then be able to verify whether their answers are right. For example, you could hide the solution for volume. You could change the height to say some other value like 6, and then you could have the students compute the volume or the surface area of this cone, and then once everyone had had a chance to do that, you can reveal the solution for volume. So one of the very useful things about this particular interactive is that it allows you to see what happens when you change different attributes of the solid. And not only do you get to kind of change the values and see the numerical answers, but you can actually visually see the cone doubling its height or having its radius as well. And so one thing you might want to do with students is that you might want to elicit guesses. What would happen to the volume if I doubled the height from 4 to 8? So in this case, if I turn the volume back on, students can see if their guess was right. In this case, if I do double the height from 4 to 8, it appears that the volume is doubled as well. Then you might say, well, what happens if I would halve the height from 4 to 2 and get guesses? Or what happens when I change the radius when I double or triple or halve the radius? And this would work as well for surface area. So for the surface area, it's obviously going to be a quite different formula, and again, maybe not the way it is presented on the SOL formula sheet. But you can go through the same process for surface area, finding out, well, this is how we practice the sort of algorithm for finding surface area. What happens if I halve the height? And so students can see that what happens for volume may not actually be the same thing that would happen for radius. In this case, when I have the height, you can kind of go back and forth to see if students' guesses are right. We've gone from 64.35 to roughly about 40. And so having the height of the cone does not have the surface area. And this can be sort of a good lead-in for asking, why is that? And see if students can come up with a correct explanation. Again, there are many different solids that are available on here: cylinders, prisms, spheres, and so on. You might find different ways to use these in your classroom. You might choose, instead of having sort of a whole class instruction, to have each student at their own computer working on these. So there's a lot of possibilities, but I think that showing the cone, showing what it looks like, the cone having a height twice as tall as the original, is really useful for students, and being able to verify whether their answers are correct are also very important.